Okay, we're going to try recording a different way this time, see if this works better. Having trouble with downloading the videos I was doing to YouTube, so hopefully this gets to you. This is going to be Geometry, Chapter 6, Section 1. I will eventually go back over, do some review stuff on Chapter 5 and even all the other chapters before this. If anybody has any questions or redos that they need to take, so you can give me comments on those. But anyway, we're going to get started with Chapter 6. Remember, you should be coming in if you haven't already. Had a few students have already come in and taken Chapter 6 vocabulary. You need to get that done within the next few days. So if you want to text me or email me when you want to come to make sure I'm going to be here. So anyway, without delay, we will get into Chapter 6, Section 1. This is where we're talking about polygon angle sum theorem. And so what we've got is, no matter what type of shape we have, that the formula is going to work out to, in that the sum of all of the angles inside the polygon is going to come out to n minus 2 times 180. And so we started, if you remember, we actually looked at this back at the first of the year, where we said, all right, let's take, for example, if we do a three-sided polygon, which obviously is a triangle, if we take 3 minus 2, if we substitute the 3 in place of the n, and then say inside the parentheses, 3 minus 2 would be a 1, and then outside the parentheses times the 180, that gives us that the total sum of the triangle inside, the angles sum inside is going to total 180. And again, we saw that, we learned that, hopefully y'all remember that from earlier in the year. Now, what we also looked at was, well, okay, let's say we look at a four-sided figure. Well, 4 means 4 in place of the letter n minus 2 times 180. And so 4 minus 2 is going to be 2. 2 times 180, that gives you a 360. Now, we looked at a perfect square, and we knew that a perfect square, or even a rectangle, any kind of parallelogram really, well, not parallelogram, but parallelogram is going to work out, but any rectangle or square is going to have 4 90s, and if we take 4 times 90, that's how you can also get to your 360. Now, that is when we're talking about the total. Remember, this is total sum. Total sum is going to be that formula, n minus 2 times 180. All right. Now, the other thing we're going to look at is whenever you have what we talked about, like in that particular case, a square, which we refer to as regular. Okay. And before we get to the word regular, we need to think about the fact that we have those things that we talked about also kind of briefly, quickly at the first of the year. And that is, if I can spell this correctly, equilateral all right, equilateral polygon. And of course, that's equilateral triangle is the most common one we've talked about. And an equilateral triangle is, that's where we said that all 3 sides of the triangle were going to be exactly equal. And so we had those little markings on each of the sides. Now, that also works out on not only an equilateral triangle, but it also comes out as equiangular. All right. And so if lateral is the sides, you can guess, and I could see, a bunch of you answering out loud, the equiangular is going to be the angles. And so that's how we knew that that angle matched that angle, matched that angle. And so all 3 angles are going to be equal. Now, hopefully you also remember when we talked about equilateral angle or equilateral triangle that it also came out to where if you were to take the 180 that you know all of the angles in a triangle have to be, if you divide that equally, because they're all equal angles, divide it by 3, then that resulted in 60 for each of these 3 angles, 60, 60, 60. And that's always going to work out. Now, when you put these two things together, when you put equilateral and equiangular, if you have any shape that has all the same sides and any shape that has all the same angles, then that's where you get to the word regular. And a regular is where, again, all the sides match and all the angles match. And so we've got, of course, an equilateral triangle where we said all the sides match and all of the angles match. But we also have a square, okay, where they all have 90s, and again, all of the sides match. Well, they don't stop there, okay? You can go to a pentagon. In fact, let me draw that. Got one of these fancy little drawer things to help y'all see this better. And so let me see if I can trace this and it works. It didn't work as well as well. Can't mash down it. Try one more time. There we go. All right, and so on this regular pentagon, regular, you know that automatically means that all of the sides match, okay? But not only are all the sides going to match, they're also going to be equiangular, which means that, okay, this angle in here is going to match all of the angles inside matching perfectly, all right? And so that's where we get to our formula for regular. So basically on any kind of quiz, test, state test, ACT, anytime you see the word regular, polygon. Now, they may not always use the word polygon. If they substitute, if you remember we took the polygon test where you had to name, depending on the number of sides, they had a certain name to it. So if it was a pentagon, a hexagon, a heptagon, all those, then as long as they have the word regular in front of that, that means all the sides are going to match and all the angles are going to match. So then you go to this formula. So it's still the same type thing, n minus 2 times 180, but now what you can do is divide that final answer you get there. Remember, this is going to be total up here. But if you divide by the number of angles or sides, it's the same thing, then what you're going to do is you're going to get each regular, if I could spell, good thing I'm not an English teacher. Each regular angle is going to come out of that. So, for example, if I take, let's say they've got here in the problem, they've got a 6, all right? And so if I take a 6-sided, let's see where I've got a 6-sided. Yep, right there. Let's see if I can trace this really well. Yeah, I did pretty well. All right, and so if I take this 6-sided figure to where all the angles are going to match, so then I would substitute in place of the n the number 6. Now everything else in the formula stays exactly the same. But again, I'm going to put a 6 in the denominator, okay, in place of the n, because I'm going to divide that total, all of them added together, divide by how many there are, and that will cut it up into equals. Now, just looking at it, think about the pentagon up there, but also think about the hexagon. Is it going to be less than 90 or greater than 90? And again, I can hear a bunch of you yelling out right now. obviously greater than 90, aren't they? Let's just prove that. And so when we substitute 6 in place of the n, and so 6 minus 2 is going to be a 4, okay, in the numerator. And so 4 times 180, and then we're going to divide that total by the number 6, and I've gone off my screen here. And so when I do that, then you're going to come out that each single regular angle is going to be a total 120. All right, so hopefully everybody understands regular. Okay, you got the total, that was your total formula. That's your total in the numerator, all right? And when you see the word regular, it's probably talking about finding each regular individual angle. And so then you divide by the number of angles you have in it, or the number of sides, and that's going to result in each individual angle in the shape that you happen to be dealing with, whether it's a whatever kind of polygon. If you got a triangle, we said it's going to come out to be 60. A square is going to be 90, and so on from there. All right, let's move on to now. That is the interior angles, but what we need to also look at is we do have what is called exterior angles. All right, and so let's start with the easy one. Let's go back to a triangle, and I think, yep, I got that on here. All right, it's not big enough. Let's do a big one. So, if I were to take this bottom side, for example, okay, bottom side down here of this base triangle, and again, if I make this a regular equilateral triangle, then it's obviously going to be the angle individually is going to be 60 degrees, correct? All right, but what I want to do is I actually want to extend this side of the triangle and make it a perfect flat side. And then again, hopefully you remember from earlier in the year, this produces what we call a linear pair. That if I were to measure the angle from here to here, obviously that's 60, but if I don't stop there and I continue all the way back around to my line, with this being the vertex, that's going to total what? Yeah, 180. All right? And so to find what we're going to call here the exterior angle, okay? The exterior angle is going to be the formula that all of them are going to have to be is 360. All right, that if you take obviously 180 minus the 60, that's going to leave you 120 there. But we're going to have 3 of those. If I extend on up here, that one's going to be 120. And then if I extend here, this one's going to be 120. And so then if I go and add all 3 of these exterior angles, then the total of the exterior, is going to be 360. Now, again, if you hear the word regular in this, okay, if they say they want the individual regular exterior, then again, all you're going to do is divide by how many you have, how many angles you have. Well, you got 3. So 360 divided by 3, and that's going to result in the 120 that we knew by doing the linear pair. Okay, so hopefully everybody understands that the 360 is going to be universal. And let me prove to that. Let's go and do a square. Okay, if I take a square, and we know that all angles in a square are going to be 90, that if I extend, okay, let me again try a different color here to help you visually see this. If I extend each of the sides out one way, okay, and then I find the exterior angle, well, again, I know that it's 360 divide by 4 is going to be 90. Well, in this particular case, because of a square, your interior 90, but also your exterior are also going to be 90 degrees. And so if you take 90 4 times, that's again how you get to 360. But again, that's going to work no matter what shape you have. Okay, so they've got an octagon. Let me pull up an octagon here. All right, hopefully that's visible for you. And so here again, this is a regular octagon that if you were to find the interior, then we would do the 8 minus 2, all right, times 180, and then divide by 8, because it's regular, all right? And so there again, the 8 minus 2 is going to be 6, right? And then 6 times the 180 is going to be 1,080. And then we divide that by 8, and that's going to give us the 135. So that's the interior, okay? Remember, that's interior for a regular, okay? So that's inside here. Well, again, what we're talking about this time is exterior. So if I were to extend that side down there, then I could find the individual by doing linear pair, subtracting from 180. But the easier thing that you're going to find is every single shape. Doesn't matter. This is what's kind of crazy, but that's why formulas are formulas, because they work all the time. Is that if you take 360 and divide by how many there are. So we've got how many? We said 8, right? So if you divide that by 8, then you are going to get 45. Okay? So that's the fast, easy way to come up with the exterior angle of a regular polygon. Whereas again, down here, we would have had to take and then said, okay, now take your 180 minus the 35, and that's how you would have gotten 45 that way. So either do the interiors, find each interior, and do linear pair, or you can do the formula, which is 360 divide by n, divide by how many angles that you have there, and that will give you each individual exterior angle. All right, so I hope that teaches you chapter 6, section 1 well enough to where you can do the problems. And again, I'll go through and practice a few more problems if needed. Please send me replies if you need more practice on this section, but I think you're going to do this one pretty well. Just pay attention when you get to the X and Y's that you have to do the algebra part, and then remember algebra, substitution, get it back to the geometry. Y'all have a blessed day.